All right, so I want to factor the following trinomials here. Trinomials, we've got 3 terms, so these first 3 are trinomials. This last one is actually just a polynomial with 4 terms, okay? So let's try some factoring techniques going on here. So when I look at this, I want to break down all the possible things that I can multiply to get 1 and add to get -2. Okay, so when I look at this, I break this down. I do my little T chart, okay, for my trinomial. So I put my number here, the -2, and then my number here, that 1, all right? And so now I look and I say, okay, how do I get 1? Well, I can multiply 1 times 1, and I can multiply -1 times -1, and both of those give me 1. Now 1 times 1, if I add those together, 1 plus 1, that's 2. That doesn't work. But -1 plus a -1 equals -2. And so this is the one I'm looking for, okay? So let's see if we can break it out, because this tells us how to break it down. Have x squared, and now instead of having just -2x in here, since I've got my -1 and my -1, I'm going to break this up to -x and -x, okay? So this splits up, so it's still the same thing. I have half of it here and half of it there, plus my 1. Now, remember, we always have to have what between our groups? We have to have a plus sign. So make sure you tuck that negative inside the parentheses there. Otherwise, you're going to have some distribution problems. Okay. So now I'm going to GCF each piece. So when I GCF this, what's in common between both of these? They both have an x. So I can pull an x out of this, leaves me x. And then an x out of this just leaves me my -1. And then here, well, how do I make this look like this here? Well, I see that that's just the negative of it, so I'm going to pull a -1 out of it, okay? And so that makes that x and makes this -1. All right, now this is great. Why? Because we've got an x minus 1 factor here and an x minus 1 factor here. And that's what we want with our GCF, because now I can pull an x minus 1 out of both of these, okay? And so what's left? I've got an x, and I have a -1, and then I close my parentheses right here. So what does this factor to? It's x minus 1 times x minus 1. Pretty cool, huh? So this could also be written as x minus 1 quantity squared. That is another way to represent it, okay? One little shortcut that might help. As long as this number in front of the squared term is 1, then once you get the -1 and the -1 here, you know that your factors are going to be x minus 1 and x minus 1. Now, if the coefficient in front of the squared term is not 1, this little trick right here that kind of speeds you to the answer without doing the double GCF, that will fall apart. But if that's 1, those are one of the easy ones for you, okay? So I guess we could use the easy trick here, because this happens to be a 1 on this next problem. So let's use the trick this time, okay? So we could see how much quicker it is. All right, so a trinomial is 3 terms, so what do? Trinomial T-chart always. So I have my -5 and then my 6. So I want it to multiply to 6 and add to -5. So let's see, 1 times 6, that adds to 7. That's not going to work. -1 times a -6, that's -7. No way. 2 times 3, that's 5. Oh, we're looking close. -2 times -3, there we go. -5 is our answer. Okay, so if you got it right off the bat, good for you. May have played a little silly there. All right. Now, since this is a 1 here, what do we know? If we've got the -2 and we got the -3, okay, then we can go ahead and write out the factored terms. X minus 2, parentheses, and then x minus 3 in parentheses. And there you go, nothing to it, right? Okay, so it's pretty sweet whenever when the coefficient of the squared term is 1, it's pretty simple, okay? Now, this one's a little bit different. Oh my goodness, we got a cube, or a to the 6th power? Goodness gracious, that seems pretty powerful. Let's see what we can do here. I might have written this problem down wrong. Let's check this. Okay. All right, let's see what we can do. All right, so what's in common between all these? Let's look at our numbers first, okay? When I look at the numbers first, all right, I see there's a 2, a negative 14, and an 8. All of those seem to be even, so they've got a 2 in common here. So I'm going to take a 2 out of each of these, all right? So I've factored a 2 out. All right, if I factor a 2 out, what am I left with? Well, I've got x6, x cubed, and then an x here. So each of these at least have an x in it. So I can pull an x out as well. So whenever I look at this and I do my little division here, the 2's cancel, so that's just a 1. X to the 6th over x is just x to the 5th. Now, negative 14 divided by 2, that's negative 7. Now, x cubed over x, that's x squared. And then 8 over 2 is 4. And then the x's cancel, okay? And when you look at this, I'm not sure this is factorable. I think that this is our final answer here. I want to say that this term is prime. All right. So a little tricky right there. Okay, this last one here, anytime we have 4 terms, we should always think factor by grouping, kind of like what we did over here, right? So when I factor by grouping, I want to group them up 2 and 2, group them up in pairs. Now, the trick I want you to remember is this. If I'm going to factor by grouping, you have to promise me that there's a plus in between the 2, okay? So that means we've got to put that negative 2 inside the parentheses here. Otherwise, the distributing becomes an issue. So now, what's in common between these two? Well, they've both got an x, so I can pull an x out of both of them, all right? So what does that leave me with? That leaves me with an a minus 2b, okay? Now, what do these both have in common? Well, how do we make this look the same? Well, right now there's a negative 2 there, so I want that gone. So I'm going to pull a negative 2 out. And then there's a y there, but there's no y here, so look at that. So I can pull a negative 2 out of this. I can pull a negative 2 out of this, because 4 divided by negative 2, that works. And there's a y in both of these, so I can pull y's out of both of them. Now there's only an a here, and there's only a b there, so that's it. So I can pull a negative 2y out, and what's left inside? Well, that's just 1a, so that's just a. And then right here, 4 divided by negative 2, that's a minus 2. And then y divided by y cancels, and I'm left with that b, okay? This is cool because now I can take this right here and factor this out. So this is why we do double GCF. So I'm pulling the greatest common factor out here. And what am I left with? All I've got left is x, and I've got a negative 2y here. And so this is about as complicated as it gets. If you can knock this one out, you are good to go. All right, guys.